Hi, everybody. We're going to do IXL Algebra 1. We're in the J.8, which is find the number of solutions. I'm assuming that they're going to give us linear equations, and they want to know, does it have one solution, all solutions, or no solutions at all? So let's take a look at it and see what it's going to give us. You want to recognize the forms that they take. Notice that we have a negative w on both sides of our equation in this one, and that in order to solve it, we would have to add w to both sides. I want to show you what happens. Let's go ahead and get my pen out. I have negative w equals negative 7 minus w, and I'm going to add a w to both sides. And this is where you really have to be a little bit careful of what you're really doing. I'm subtracting or having a negative w plus w, which is 0, and that is equal to negative 7 plus 0. Well, this is not true, and there is no w that will make 0 equal to negative 7. So there is no solution for this equation. When this occurs, when you have the same coefficient on your variable and different numbers, it will always give you no solution. Now, in this case, negative 8c plus 8c is equal to 0. This is true. In fact, it's true for any c that we're talking about. Realize that c could be any number. If I put a 1 in there, you get negative 8 plus 8 is equal to 0. If c were 2, it would be negative 16 plus 16 is 0. So because this is always true, it's called an identity sometimes. In this case, you could have added 8c to both sides and it would have been 8c equals 8c. But this is an infinitely many solutions. This one, you can see again that we have a negative 4d on one side and a negative 4d on the other side. On the left, it's just being added to 0, and on the right, we're subtracting 4. So we're going to end up with them being not equal. If I add 4d to both sides, I get 0 is equal to negative 4, which is not true. This is not true. And no matter what d I put into the equation, it will never be true. And so it is no solution. Let's see. This one is true, and it's always true. So it's infinitely many solutions. This one is just slightly disguised. Is the equation an identity? Is 4w equal to 4w? And of course it is. See that 6w plus negative 2w is 4w. Notice that I have a 10s on the left and a 10s on the right, but the numbers are different. That means that since a negative 9 will never be equal to 7, it's no solutions. In this case, we have negative 3b is equal to negative 3b, which is an identity. It has infinitely many solutions. This one you have to add like terms. So we have a negative d and a negative 5d, which is negative 6d, and it's being added to 1. And then I have 1 minus 6d. And notice that we have a negative 6d and a negative 6d, and 1 is equal to 1. If you wanted to, you could add 6d to both sides, and it's true. And yes, it is true. And this one, notice that the coefficients on my variables are different. Whenever this happens, you have one solution. In this particular case, we could find it by subtracting 9z from both sides. And, sorry, this is negative 2. And then adding 7 to both sides, which would give you z equal to 5. But that is one solution. Almost hit the wrong one. No, looked like 1. All right, in this one, we have negative 2y equals negative 2y, which is an identity, And that's infinitely many solutions. And looks like we're almost to the proficient level. In this one, we have different coefficients on our variables. So in this case, I have 10p minus 5 is equal to, notice that the -4 plus the, -9 plus 4 is -5, plus 9p. 9p and 10p are not the same. The -5 is the same, but the 9p and the 10p mean that I am going to get a solution. There's only going to be one solution, so no, it's not an identity. If it's an identity, you have an infinite number of solutions, so this is a no. In this one, they are identical. -7 minus 3g is the same as -3g plus 7. So it is an identity, and we have infinitely many solutions because it's true. In this one, we're going to add the 4t and the 12t together, and so we get -19 plus 16t is equal to -19 plus 16t. And yes, it is an identity. All right, I'm going to quit writing them out. I'm just going to do them in my head. Is this an equation an identity? Of course not. No. This has a -8 and this has nothing on it. This one, we have a 9.4j, but the numbers are different. That will never be true. In this one, we have a -14f and a -14f. We have a -0.85, and this is definitely not the same. So this is no, not an identity. -4.15 or -1.45 added to 19.01 is certainly not going to give us a negative decimal. This one is no solution, and the reason is our variables are the same, but the numbers being added to them are different. There's a 0 added to this side and -2.23 added to the right. So this would be no solution. In this one, we've got an addition going on there, and it may actually be this. It's not, if you're not careful, -1.8n. Actually, maybe it is. Let's see, 13.8. And we have a -15.6. And that gives us a 0.8. And we had to borrow. And that's 1.8. And the negatives win. Yep. So the ends are the same. And the number being added is the same. So yes, it's an identity. This is an identity because it's always true. Almost done. How many solutions does it have? Well, we have a -18m plus 36 on the left, and we have 3m plus 27 on the right. And that means because these are different, you're going to definitely have one solution. That will always be the case. In this one, you have to distribute the 5 to both parts, and it is not going to be an identity, no. This one, you're going to distribute the -2 to both parts, and you're going to have 16y plus 16 when you distribute the 2 on the left. And on the right, you're going to have 16y plus 16. And of course, it is an identity. And I'm going to distribute the -2. That's going to give me 12 plus 24u. And on the right, we distribute the 6, and we get 24u. And 6 times 18 looks like it's going to be 108. Huh? And these are not the same. The 108 and 12 are different, even though the 24u is the same. If they had been the same, then it would be an identity and it would have an infinite solution. This is no solution. And a few more, almost done. This one we have to distribute the 3, and it is true. We get 3q minus 15, so yes, it's an identity. How many solutions? Well, we've got a negative 36p plus 48 when we distribute the 3 to both parts on the left, plus 4p. So I end up with negative 32p plus 48 on the left. On the right side, we just simply distribute our negative 4, and we get negative 32p plus 48. And they definitely look alike. They are the same, so it is infinitely many solutions. Maybe one more, maybe 2. We get negative 14d plus negative 35 when we distribute. And on the other side, we just have negative 14d. There is no solution to this. And definitely another one. All right, we have a negative 7r minus 16r, which is minus 23r, minus 16 on the left. And we have to distribute this negative 4 to both parts. Need to be very careful. Negative 8 and negative 15 is negative 33, I believe. Let's double check. And we do get a minus 16. Boy, it's easy to make an error there, isn't it? Oh, it's a negative 8 and 15 is negative 23. Yeah, it's okay. Those are the same. Looks like it's the same. It looks like it is an identity. And we have one last one. We have to distribute 9. Negative 20 minus 19. Wait, no. I touched my screen. I got to be careful not to do that. All right. This one looks like no solution. See how many more it makes me do. Probably 3. This one, 6 times 18h is the same. And I get a negative 12. And on the other side, I get a negative 12. So it's infinitely many solutions. Maybe 2 more. This one, we're going to distribute the negative 3 times 15 is negative 45. And 19w is going to be different. It is not. This is definitely a no. And one last one. This time we're distributing the negative 2 to both parts, and it has one solution because we end up with positive 2f on this side and 1f on that side. So it's one solution. And now we're done. So hopefully you don't make an error like I did and touch your screen too soon. And keep practicing. See you soon. Bye, everybody.